Okay, so hi everybody. So today I'm going to talk real quick, and this is to allow you to be able to do the 5-minute math episode 2, the Vieta's formulas. So today I'm going to go ahead and I'm going to do my best to explain what Vieta's formulas are. It's quite complicated, and it can make a kind of a big jump into rings later on, but you don't need to worry about that. Okay, so these are called Vieta's formulas. Okay. Now, generally speaking, what it has to do is it has to do when you have a polynomial of the nth order. So you have a of n, x to the power of n, plus a of n minus 1, x to the n minus 1, plus a of n minus 2, x to the n minus 2, all the way down to a1 x to the power of 1, plus the constant term, which is a0. Okay, so that's what we have. If we have this nth degree polynomial, is there some relationships there between the roots? Okay, well, we know by the first fundamental theorem of algebra that this has n roots to this polynomial. Okay, they may not be distinct roots, but it has n roots. They may not even all be real roots. Some of them could be complex, but it does have n roots. Okay, so here's what I know. I know that the sum of these roots is given as negative a of n minus 1 all over a of n. Okay, so whatever this polynomial is, all I have to do is take the negation of this coefficient and put it over this coefficient, and it gives me that value. Okay, now let me do a quick explanation. This is not a proof by any means. This is just a demonstration of a quadratic. Okay, so say for example you have a quadratic. So explanation. Okay, so say you have some sort of a quadratic, and that quadratic is in the form a2 x squared plus a1x plus a naught is equal to 0. Okay, well, according to what we had up here, I should have the sum of the roots is going to be equal to negative a of n minus 1. Well, this is a of n, so a of n minus 1 will be a1. So it should be negative a1 all over a of n, and a of n in this case is a2. So that's what I should get. Now, let me explain how I do this. Now, so say, for example, we have roots here. This polynomial has roots, and I know that it has 2 different roots because it is a second degree order polynomial. So we're going to let P and Q be the roots of this polynomial. Okay. So what I know is I know that I can rewrite this polynomial as x minus p times x minus q is equal to 0. I'm missing something, so just hold on. And we know that we could do this. This goes back to, I think, Algebra 1 or Algebra 2 days or something like that. We can rewrite it like this. The problem is this leading coefficient is not 1, it's a2. So what I'm going to do is I'm going to factor an a2 out of all of this. So factor in an a2 out of this, I'm going to have a2 is equal to, well, x squared, plus, if I take an a2 out of a1, I'm left with a1 all over a2x, and then plus a naught over a2. Okay, and then I have to put the a2 over there. Okay, so now I'm good. Now I can go ahead and proceed. So you notice they both have the a2 there. I'm going to cancel this. Now what I'm going to do is I'm going to distribute this, and then I'm going to compare and contrast the right-hand side with the left-hand side. Okay? So the left-hand side stays the same. So I have x squared plus a1 all over a2x plus a naught all over a2 is equal to x squared minus p plus q plus pq is equal to 0. Now let's compare and contrast. Oh, I'm missing an x here. What do you know about the coefficient of x over here? It is a1 over a2. And what do you notice about the coefficient of the x over there? It's negative p plus q. So therefore, equating these two, I have a1 all over a2 is equal to negative p plus q. So p plus q, which is the sum of the roots, is equal to negative a1 all over a2, which is exactly what I saw up there. Okay? So that's the sum of the roots. What about the product of the roots? You guys could guess what it is right here. Look, there's the product of the roots here. Okay? So as a general formula now, okay, so as a general formula for the product of roots, this is going to be equal to negative 1 to the power of n, where n stands for the degree measurement of the polynomial, a naught all over a n. Okay, so once again, according to this equation right here, which I just gave you, and we're going to once again do the explanation here. I have a2x squared plus a1x to the first plus a naught is equal to 0. By this equation, the product of the roots should be equal to what? Negative 1 to the power of 2, because it's a second order polynomial. Well, that's just 1. Times a naught is, well, a naught, and an is a2. So this is a2. And that's exactly what that's what I should get according to this equation. Now, once again, let's go back up here and let's use this to explain where that comes from. Once again, if p and q were the roots, I could rewrite this polynomial like this, factoring out the a2, which is equal to this. You distribute everything, and so what you get is you end up getting p times q, which is the product of the roots, is equal to a naught over a2. Well, hey, that's exactly what I said before. Okay? So here's what the things that you need to know are. Right now, you need to know what this equation is. Okay, that's one of them. And the other equation you need to know is right here. Okay, so there we are. Okay, there's one other equation that you'll need to know here. Okay, and it's a little bit different. And it's not the product of the roots and the sum of the roots, because it's kind of a combination of the two of them. So what it is it's, so if you have n roots, okay, so you have a polynomial, which is an x to the power of n plus an minus 1 x to the n minus 1 plus all the way down to a2x squared plus a1x plus a naught is equal to 0. And we let P1, P2, P3, all the way up to Pn be the n roots of this polynomial. Okay, so that's what we have. So here's the formula you need to know. And there are others, but I'm just going to stop at this. This is going to be the third and last one I'm going to deal with. Just know that you could make an extension going further than this. Okay, and that's if you have P1, P2 plus P1, P3 plus all the way up P1, Pn. So in other words, I've taken all the P1s and I've multiplied them by all the other roots and I've added it together. Okay, plus P2, P3. So now instead of starting off at P1 and going all the way up, I'm starting at P2 and going all the way up. So P2, P3 plus P2, P4 plus all the way up to P2, Pn. Okay, and you basically continue this pattern. So plus dot, 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 plus. Now what's going to be the last one? So we started at P1 and did all the rest. and then went to P2, did the rest, and P3 do all the rest, P4 do all the rest. The last thing you can have there then is P of n minus 1 times P of n. That's the last one that can take place there. Okay? So what is this equal to? This is equal to, according to this equation where these are the roots, okay, that go right here, this is equal to a of n minus 2 all over a of n. Okay, so this is the last formula that you need to know. Now, the other two formulas for the sum and the products, those are really important. But to be honest, like from all my years of experience with competitive math, that's kind of like middle school math, like competitive math. Those are the equations that you would use in middle school to be really good. If you're going to be really good in high school, you also need to know this formula because this one ends up coming up a lot as well. Okay? I'm not going to do an explanation of this, but I could do it, but it's based off of doing a little bit crazier multiplication, and I'm not going to go through and do that because I don't think that's imperative. But it would be basically the same type of derivation that you would get doing this way. Okay, so that's Vieta's formulas. I hopefully you guys are able to kind of get the gist of it. But there's 3 formulas you really need to know. Okay, here's one: the sum of the roots. Here's 2 right here: the product of the roots. And the third one is this really kind of bizarre one right here, where it just takes a combinations P1, P2, and then it's a combination of product and the summation of them. Okay, so those are the 3 formulas you'll need to know. Okay, thanks everybody. I hope you guys enjoyed. Have a good one.